Good afternoon. Well, good evening now, yes, and welcome to the A-Level Physics Talk for Elaine's Academy. I'm Mr. Mayland, and I'm going to be taking you through this evening. I am on my third attempt at filming this, by the way, so most of my enthusiasm for this is out of the window and been replaced by rage at this point. So I'm just letting you know. Right, so what is physics? Well, it's the study of everything, really. It's the study of all the laws that nature, that matter has to follow in this universe. So whether you're a giant galaxy that's a million kilometers wide, or a teeny weeny tiny little atom, okay, the laws that apply to the atom apply to the universe as well. And physics is just the study of those laws, really, making sense of them. This is us in the universe, by the way, that little circle down there, roughly where we are in the Milky Way. As I said, the Milky Way is big. It's really big. A million kilometers across, in fact. Impossible to comprehend. And then we've got this thing down here, which is 1 times 10 to the minus 9 meters across, which is a femtometer, which is unbelievably small, okay? Right, so jumping on then. Some transferable skills you'll pick up from physics at A level. So maths is obviously the big one. Maths plays a big part in physics. Maths is a tool that we use to explain ourselves, okay? So it's like a language, really. It's the language of science, maths. It was invented by physicists to explain things, right? A big part of physics is problem solving as well. So it's using logic, analyzing things critically, okay? Looking at different situations and trying to apply what you've learned in one situation to somewhere else, right? And that ties in with your practical skills as well. We do a bunch of practicals. I'll talk about them in a little while. They're called required practicals, but we'll pick up a lot of practical skills along the way that are applicable to all manner of different things. So with the problem solving, you've kind of got your application skills. So again, apply knowledge to different situations based on what you already know. And then you've got stuff like data collection, analysis, evaluation skills. They all kind of tie in with your practical stuff, really. So conducting experiments, designing experiments, gathering data, analyzing that data, evaluating it. This is all skills that people are after these days when you get out into the wider world. So course content. Break it down into 2 years. Who'd have thunk it? You've got year 12 and year 13. Year 12, we cover, for the most part, electricity, fundamental particles, quantum, optics and waves, forces, and equations of motion. So electricity, forces, and equations of motion, you will have done a little bit of these at GCSE. We very much build on them at year 12. The course is built for combined science, not triple science. So as long as you've got a science GCSE, you've got the base knowledge you need to do A-level physics, okay? You don't need to do triples to be able to do it, is the point I'm getting at. The opposite, in fact. Year 13, we cover circular motion, simple harmonic motion, gravitational fields, EM fields, thermodynamics, nuclear physics, and an optional module. There's 3 optional modules. You have astrophysics, medical physics, and I think it's like engineering or philosophical physics, something like that. Turning points, that's what they call it, turning points. We usually do, in fact, every year I've been here, we've done astrophysics. Reason being, it's the most enjoyable out of the lot by far, and it also has the most applicable skills. It doesn't just apply to space astro. A lot of the stuff you pick up there apply to many other different situations. Whereas the medical physics and the turning points are kind of like honed in, focused on something. So unless you're doing medical physics, for example, at uni, it's not really applicable. Whereas astro is applicable to everything. But yeah, we'll be covering things you already picked up at GCSE and just expanding on those more. In terms of delivery, you'll be taught by 2 staff members. One of them will have you for 6 periods over a fortnight. The other one will have you for 3. So you get 9 hours in total. The teacher with the 6 periods will get you for a 2-hour double session. And that's so we can do our required practicals because they take a lot of time to do. And then you'll have about 4 hours of theory with them. And then with teacher 2, you'll have about 3 hours of theory. Now, obviously, you'll do practicals with teacher 1 and teacher 2 It's just that one of the sessions is reserved just for required practicals, and that will always be with teacher one. So in terms of assessments, big one is this practical endorsement. So there's certain practicals you have to do throughout the 2 years, and there's basically a checklist. And if you complete the practical, wow, you get ticked off on these skills. And what we're going to be doing over the 2 years is building up a bank of these skills, and then at the end of it, we can go to AQA and we can say, I've done this practical, this practical, and this practical, so I've got all of these skills. And they say, great, have your practical endorsement. It's basically impossible to fail. And we're going to be doing weird things like this, measuring the voltage out of potatoes and things like that. There'll be 3 exams at the end of the 2 years to go along with your practical endorsement. Paper 1, roughly speaking, is first year. Paper 2 is all your second year stuff. And paper 3 is your practical questions and an optional module. So it'll be astrophysics and questions that are based on the required practicals. In terms of entry requirements, if you're doing combined science, we want a 5/6 minimum plus a 6 in maths. If you're doing triple, we want a 6 in physics and a 5 in maths. These entry requirements are a minimum. Physics is a very difficult A-level. A-levels in general are much more difficult than GCSE. The step up is huge, and the step up to physics is even bigger. You very much need an analytical mind, okay? You need to be confident in your maths, or physics is definitely not the subject for you. I'd say physics and maths are easily the 2 most difficult A-levels you can do at the moment. But that pays off, right? Because it makes it very attractive. That's why you'd want to do A-level physics. Employers love it. Universities love it, because if you can get a half decent grade at A-level physics, it shows that you're capable of doing a lot of stuff. You pick up loads of broad ranging skills, okay, that are transferable to loads of situations. It's basically like getting a key to most doors that you want to open, right? It's really, really good to have. It's really attractive to universities and employers when you go out into the wider world. Just quickly, a few combinations that are good with physics. Chemistry, so there's a lot of crossover and a lot of different units there that really, really work together well. Biology helps a little bit with like data analysis, interpreting data and extended writing. And then obviously the big one is maths. Further maths is great to have. Further maths will put your understanding on a complete other level compared to anyone that doesn't do it. However, it is not at all necessary. You don't have to do further maths at all. It just very much helps with your understanding of things. So few trips we usually go on, not as fancy as the business trips, unfortunately. But we go to Keele University quite a lot, do loads of practicals up there because they've got nice new shiny labs, nice new equipment and all that stuff. And we usually do the A-level science live talks. There a couple of times a year, get loads of guest lecturers in, giving you loads of talks on physics and like exam technique and all that good stuff. There's a few other trips we go on dotted here and there. Trying to organise a CERN trip this year as well to Switzerland, but we'll see how that goes with all the new visa requirements and such. Right, if you do have any questions, please just drop me an email at j.mayland@allains.staffs.sch.uk, and I will be more than happy to answer. Might be a little bit slow to reply, but I will reply to you. I promise you that much. Right, thank you very much for listening. I hope you enjoyed listening to my dulcet tones, and enjoy the rest of your evening. See you later.